Absolute value equations and inequalities. The definition of absolute value is written, and then we have the bars, vertical bars, and some number a, and it's the undirected distance from a to 0 on a number line. A few cases we might have. So our first case, the absolute value of x is equal to k. So we'll have x is equal to k or x is equal to negative k, because this is the distance on our line that doesn't have any direction from a to 0. So our graph will look like this. And then our solution set would be negative k, comma, k. Another case we might have is the absolute value of x, instead of an equals, is less than k. So when it's less than k, we have negative k is less than x, which is less than a positive k. And in this case, we'll have our negative k to k, and our solutions will be contained within both of those values. Last case is x is greater than k. So for this case, we'll have x is less than negative k or x is greater than k, and this will be going towards the outsides. So with that in mind, let's go ahead and look at solving some absolute value equations. For our first example, we have the absolute value of 9 minus 4x is equal to 7. So if we remember, this is the same thing as our first case, x is equal to k or x is equal to negative k, because we're dealing with this equal sign. So let's go ahead and write those out. We have our 9 minus 4x is equal to 7, or 9 minus 4x is equal to negative 7. So go ahead and solve both equations for x and see what values you get. Let's go ahead and subtract a 9. Negative 4x is going to be equal to a negative 2, and then divide by negative 4. That should get you a positive 1/2. Okay, and then finally we will have a negative 9 minus 4x is equal to negative 7. Let's go ahead and subtract a negative 9. This will get us negative 4x is equal to negative 16. Divide by negative 4. And you're left with x is equal to 4. So go ahead and test these inside of your original equation, see if they make sense, and then if they do make sense, then you can include them as a solution. So let's test this 1/2 first. We will have the absolute value, 9 minus 4 times 1/2. And let's see if that's equal to 7. We get 9 minus, and then 4 divided by 2 is going to be 2. So absolute value of 7 is equal to 7. That makes sense. Let's go ahead and check that one. And our other one we have is absolute value of 9 minus 4 times 4 equal to 7. So we'll have absolute value of 9 minus 16 is equal to 7. And that will be the absolute value of 7 is equal to 7, or 7 is equal to 7, which makes sense in our case. So we can go ahead and include both of these as solutions. Now for our next example, we have two x's on the right and left hand sides. Let's go ahead and try to solve for these. So first things first, we want to go ahead and set up our equations. So our first one will have 3x plus 2 is equal to a positive x minus 5, or 3x plus 2 is equal to a negative, and then do an x minus 5. So go ahead and solve for x in both of these equations. We'll go ahead and add a 2 over, and go ahead and add or subtract the x over, and this will give us a 2x is equal to negative 7, and also divided by 2. X is equal to negative 7 halves, or, and let's go ahead and deal with this other equation. So 3x plus 2 is equal to negative x plus 5. Go ahead and subtract the 2 over and add the x. 4x is equal to 3, or x is equal to 3/4. Finally, test these back into your original equation. See if they make sense so you can determine if you need to include these or not. So 3 times negative 7/2 plus 2. And then we want to see if that's equal to the absolute value of negative 7/2 minus 5. So this will give us a, easily simplifying here, we'll just have a negative 17 divided by 2, and that's going to be equal to a negative 17 divided by 2, which makes sense because that'll just be 17/2 equals 17/2. So that one makes sense, and we can check our other one, which will be this 3/4. So go ahead and plug 3/4 in. Absolute value of 3 times 3/4 plus 2, and that's equal to the absolute value of 3/4 minus 5. This will give us a positive 17/4 is equal to the absolute value of negative 17/4, which makes sense because that'll just be 17/4 divided, or equal to 17/4. So our solution set here, we can finally write, will be negative 7/2, comma 3/4. Another case that we'll have is when we have inequalities from our cases 2 and 3. If we go back up, we have cases 2 and 3, which is when it's less than, or when the absolute value of x is greater than k. So let's go ahead and take a look at this one. We have the absolute value of 4x minus 6 is less than 10, and we want to go ahead and solve for x. So first things first, we have to remember what we need to do in order to set this equation up. So unlike the other one, we will now have our x sandwiched in between a negative k and a positive k. So let's set our equation up correctly. We will have 4x minus 6, and that will be less than 10, and also a less than negative 10. Okay, so go ahead and get your constants on the right and left hand sides. Add 6, and add 6. So we'll have negative 4 less than 4x minus 4x, and then just less than 16. And then go ahead and divide by 4. So you'll be left with a negative 1 is less than x, which is less than 4. And this will be our solution here. Negative 1, 2, 4 for our notation if we go back up for our final result. Okay, so our last one is case 3, where x is greater than x. The way to set this one up, you'll have either x is less than negative k or x is greater than k. And then remember, our final solution will look something like this. Okay, so for our next example, we have the absolute value of 5 minus 8x plus 6 is greater than or equal to 14. So one thing that will make our lives a little bit easier, go ahead and get that 6 over with the other constant. We're left with the absolute value of 5 minus 8x is greater than or equal to 8. And now we can go ahead and deal with our case number 3. So we will have a 5 minus 8x is less than or equal to a negative 8, or we will have a 5 minus 8x is greater than a positive 8. Okay, and we can go ahead and deal with our constants here. So we'll have a negative 8x is going to be less than or equal to negative 13 divided by negative 8. And since we're dividing by negative, we do need to flip our signs. So x will be greater than a positive 13/8. And then our other equation, go ahead and subtract the 5. Subtract the 5. Negative 8x is greater than or equal to 3 divided by negative 8. X is less than, need to flip your signs because we're dividing by a negative, negative 3/8. So our final solution, we have x is less, or x is greater than, so if we think about this on a number line, we have 13/8 here, and we have negative 3/8, and it's essentially saying that our x is greater than or equal to all these values, and then x is less than or equal to negative 3/8. So it'll be all the values this way. So our solution for this one, negative infinity to negative 3/8. And since we have a greater than or equal to, less than or equal to negative 3/8, we do need to use our square braces. And then union 13/8 all the way to positive infinity. Solving some special cases here, we have 7x plus 28, and now we're setting it equal to 0. So let's see what we need to do here. Again, and this will be our first case since we have an equal sign. So we have 7x plus 28 equals 0, or 7x plus 28 equals negative 0. Well, this is just 0 in both cases, so we really just need to solve one equation. So we'll have a 7x plus 28 equals 0. 7x is equal to negative 28, or x is equal to negative 4. So we really just have one solution here, which is going to be our negative 4. Example 2. Now we're dealing with a negative number, so let's think about this for a second. If our absolute value is greater than a negative number, what will this be? Well, it's going to be all real numbers because the absolute value is always going to be non-negative, right? So in this case, let's think about this. If we plug in a 1, so absolute value of 6 times a 1 minus 9 greater than negative 2, we'll have a 6 minus 9 greater than negative 2, which would be the absolute value of a negative 3, which would be a 3 greater than negative 2. So it doesn't matter what number we plug in here. We could literally plug in 1,000, and for x we could plug in negative 1,000. It's always going to be true because regardless if we get a positive number or if we get a negative number, the absolute value of that is always going to be greater than a negative. So in this case, what we can say is all reals can also be written as negative infinity to positive infinity. One more special case, 2 minus 5x less than or equal to negative 5. So the answer to this one is that there's no number whose absolute value is less than negative 5. Why is that? Well, again, let's plug in some values here. Say we plug in a 1 less than negative 5. We'll get the absolute value of 2 minus 5 less than or equal to 5, which would be the absolute value of negative 3. which is just 3 less than or equal to -5, which definitely doesn't make any sense. So it doesn't matter what number we plug in here, the absolute value is always going to be positive. So let's say no number, use absolute value, less than -5, or we can just do this for no solutions here. Absolute value inequalities with distances. We want to write each statement using an absolute value inequality. So for our first example, we have m is no more than 9 units from 3. So if m is no more than 9 units from 3, we know that we'll have the absolute value of something, and then this keyword no more here tells us that we're going to be using a less than or equal to, and we have a 9 units. So m is no more than 9 units from 3, and that will be our solution here. T is within 0.02 units of 5.8. So we want to figure out what our distance is. Distance is 0.02. So it's within. Within is a key because it means it's going to be contained in and not including that potential value. So you're going to want to use a less than 0.02 units. And then we know it's going to be the absolute value because we're talking distance here. So T is within 5.8 units of, or within 0.02 units of 5.8. Using absolute value to model some tolerances. So suppose y is equal to 5x minus 2. We want y to be within, again, that's going to be a keyword, meaning we want to use the less than sign, 0.001 unit of 6. For what values will x be true? Let's set this up. We know that it's going to be within, so it's going to be contained within there. And then our unit is 0.001, and our equation is y is within 0.001 unit of 6. So if it's within that unit from 6, we can go ahead and say y minus 6. And we want to go ahead and plug in our other equation that we have, which is y is equal to 5x minus 2. So let's plug that in. Okay, so doing a little bit of simplification here, we will end up with the absolute value of 5x minus 8 is less than 0.001. Now, if it's within, we know that we're going to have our 5x minus 8 sandwiched in between these two values. So 5x minus 8, and then we'll have the positive 0.001, and then we'll have the negative 0.001. Go ahead and take care of your constants on both the right and left hand sides, and that will leave us with 7.999 less than 5x, and that will be less than 8.001. Divide right and left hand sides by 5, and you're left with 1.5998 is less than x, which is less than 1.6002. So your final solution, you can go ahead and write 1.5998 and 1.6002.